In this lesson, we're going to learn about the law of conservation of momentum. Remember, definitions are very, very important. You get a lot of marks in the examinations for definitions. Each definition will give you 2 marks. So make sure that you know these definitions. The total linear momentum of an isolated system remains constant, meaning that it is conserved. Remember, we discussed about the isolated system in the previous lesson. It is conserved, meaning that it does not change. Let me explain this further. Let's consider ball A and ball B. So we have 2 situations here. The first situation is before collision, and then the second situation is after collision. What does the law of conservation of momentum say? The total linear momentum of an isolated system remains constant. Right, so it means that the total momentum before collision is equal to the total momentum after collision. That's what it means. Okay, so now we have the total momentum before collision. Let's say this is total momentum initially. You can write it like this using sigma notation from mathematics. Remember, this means the sum of initial momentum. Okay, so it's going to be equal to the initial momentum of ball A plus initial momentum of ball B, right? And then this side, after collision, which is the final momentum here. So we have the total final momentum, and then we can use sigma notation, meaning that sum of final momentum is going to be final momentum for ball A plus final momentum for ball B. Right. So according to the law of conservation of momentum, the total linear momentum of an isolated system remains constant, meaning that this and this must be equal. They must be equal. So in an isolated system, the sum of initial momentum is equal to the sum of final momentum. Okay, meaning that initial momentum of A plus initial momentum of B is equal to final momentum of A plus final momentum of B. Okay, and then remember, momentum is mass times velocity. We can write this as ma, velocity of A, the initial velocity of A, that's that. This is just this. Then plus mb times initial velocity of B. This is mass of B. ma means mass of A. mb means mass of B. And then VIA means the initial velocity of A. VIP means the initial velocity of B. Right, is equal to mass of A times final velocity of A. These are subscripts. Okay, and then plus mass of B times final velocity of B. So this is the law of conservation of momentum. So we're going to be using this formula a lot in the examples. Let's go to the examples. Right, we need to take a lot of our time on the information because it's very easy to substitute and calculate the final answer. So we need to spend a lot of time on the information and make sure that we don't make mistakes. A 2 kg block is at rest on a smooth, frictionless horizontal table. A bullet of mass 0.015 kilograms traveling east at 400 meters per second strikes the block and passes straight through it with a constant acceleration. Refer to the diagram below. Ignore any loss of mass of the bullet and the block. The block moves eastwards at 0.7 meters per second after the bullet has emerged from it. Calculate the magnitude of the velocity of the bullet immediately after it emerges from the block. So what information do we have here? Right, let's have the information about the bullet, but let's choose our direction first. Let's say our positive direction. Let's make it east. Right, what information do we have about the bullet? So the mass of the bullet, what is it? 0,015 kilogram. Let's write the units because they're very, very important. And then we have the initial velocity of the bullet. Initial velocity of the bullet is 400 meters per second. So it's going to be positive because it's going to the east. So it's 400 meters per second. And then final velocity of the bullet, that's what we're looking for. Okay, all right. It says calculate the magnitude of the velocity of the bullet immediately after it emerges from the block. And then the information about the block. So the mass of the block, let's use B, capital letter B, is 2 kilograms. The initial velocity of the block is equal to 0 meters per second, right? Because at the beginning it is at rest. The final velocity of the block is 0.7 meters per second. That's what we have here, right? Now we have the information that we need. And then now remember the law of conservation of momentum. The sum of initial momentum is equal to the sum of final momentum. So meaning that mass of bullet times initial velocity of bullet plus mass of the block times initial velocity of block. So this is the momentum of the bullet plus momentum of the block initially. Then the final, we have mass of bullet times final velocity of bullet plus mass of the block times final velocity of the block. Okay, right, let's substitute what we have. So we have 0,015 and then 400. Okay, then plus 2 times 0. Okay, this is the initial momentum is equal to mass of the bullet 0,015. Then final velocity, that's what we're looking for, plus 2 for the block, and then 0,7. Okay, right, we have substituted now. Now we're looking for this, the final velocity of the bullet. So what we can do, we can subtract this from both sides of the equation and divide by 0,015. So it becomes 0,015 times 400 plus 2 times 0, or you just get rid of this because it's 0, it doesn't change anything, minus 2 minus this 2 times 0,7 divided by 0,015. Then this will give us final velocity of the bullet. Okay, then you can use your calculator here, get that the final velocity of the bullet is equal to positive 306,67 meters per second. Since it's positive, so it's going to be east. Right, let's do example 2. All right, again, it is very important that we read the information and make sure we understand. It says, a car of mass 1000 kilograms is moving on a horizontal road at a velocity of 40 meters per second east. The car collides head-on with a truck of mass 5000 kilograms moving at 20 meters per second in the opposite direction, means moving to the west. After the collision, the car and the truck move together. Very important there. It means they combined. Ignore the effects of friction. All right. State the law of conservation of linear momentum. Check that. This is from an examination question. So we have to remember the definitions. What did we say? The total linear momentum in an isolated system remains constant or is conserved. Let's write that. All right. The total linear momentum in an isolated system remains constant, or we can say is conserved. That is A. Then B, calculate the velocity of the car immediately after collision. So we want to find the final velocity of the car. But after collision, these two objects are combined. So we're going to have the velocity of the combined objects. Right? What information do we have? We have the mass of the car. Oh, what is our direction? Let's choose our direction. Positive direction. Positive. Let's say east. Right. Then the information for the car. We have the mass of the car, which is 1000 kilograms. Right. And then we have the initial velocity of the car, which is equal to 40 meters per second. It's positive because it's going to the east. And then we have mass of the truck, which is equal to 5000 kilograms. And then we have the initial velocity of the truck, which is going to be negative 20 meters per second because it's going to the west. Right. And then the final mass of these two objects is going to be the mass of the car plus mass of the truck. Okay. And then the final velocity of these two of the combined objects is what we're looking for. So now we have the sum of the initial momentum is equal to the sum of the final momentum, right? So meaning that mass of car times initial velocity of car plus mass of truck times initial velocity of truck is equal to this one. We have to be careful because it's combined. After collision, these two are combined. So it's going to be mass of car plus mass of truck, okay, times the final velocity. Okay, because their velocities are going to be the same anyway. Because if we do it like this, mass of car times final velocity of car plus mass of truck times final velocity of truck. Then since these two are the same, we can factor it out. We can factor it out because they're just the same of the truck here, sorry. But they're just the same, so we can factor it out and remain with mass of car plus mass of truck times final velocity. Right. And then let's just substitute what we have. So it's going to be, let me use this space, 1000 times 40. Okay. And then plus 5000 times negative 20 is equal to 1000 plus 5000 times the final velocity of the combined objects. So what we do, we can divide both sides by this. So it's going to be 1040 plus 5000 minus 20. Okay, all this divided by 1000 plus 5000, right, is equal to the final velocity. Then what do you get? Final velocity is equal to negative 10 meters per second. This is east. But now, since it's negative, means that it's going in the opposite direction. So final velocity will be 10 meters per second west.